So we have to limit our quadrants. If the problem starts with the inverse, that's when you are only going to give me one answer. Because these will not start with an inverse, we are going to have to tell every angle on the unit circle that would make them true. So our first problem, I want to solve 3 tangent of theta minus radical 3 equals 0. Okay, so first we're solving this in degrees. When I say over the interval 0 to 360, I want degrees. So I have to find theta. Just like if you're solving in the other equation, we have to get the theta by itself. So I am going to add over my radical 3. Then we can divide by 3. Okay, you notice this is not an inverse. So I'm looking at all 4 quadrants on the unit circle. I want to know every time tangent would equal radical 3 over 3. So we've done this type of thing before. What quadrants would tangent be a positive in?
Quadrant 1, 1 to 3.
So you will have 2 answers, one for each of those. Reference angle. When is tangent radical 3 over 3? 30 degrees. So in quadrant 1, 30 degrees is 30 degrees. In quadrant 3, 180 plus 30 is 210 degrees. That's part A. We could always check these if we wanted to. If we plug them back in, it should work out. Part B, when I say all possible solutions, okay, so this worked at 30 degrees, and if you go all the way around the circle and come back to 30, it works again. And if I go around again, every time I hit that value, it would happen, right? So for all possible solutions, you take your answer plus 360 degrees K. K is an integer. Remember that double bar Z. That just means it's an integer. It's like 1, 2, 3, -1, -2, -3. It's just saying every time I come around the circle, I would hit that. You have to include that plus 360 when I say all solutions, when I don't give you a stopping point. You could do the same thing for the other one. 210 plus 360 degrees K. There are some other ways of writing it, some other tricks that sometimes work, but the easiest is just to keep it the plus 360K, and that'll work every time.
What did you do to get that 210?
It was in quadrant 3, so if you're in quadrant 3 and this reference angle is 30, to get the whole thing, you have to add 180 to it.
Okay.
Other questions? Okay, let's do another one like that. So what would we do first? Okay, so this is not sign inverse, so I want every quadrant on the unit circle that makes sign negative. So that would be?
Quadrant 3, quadrant 4.
Reference angle. When is sine 1/2? 30 degrees. Okay. So 30 degrees in quadrant 3, so 180 plus 30 is 210. In quadrant 4, you would do 360 minus 30, so that's 330. So that's part A, every answer between 0 and 360. How do I do part B, all possible solutions? we should state k is an integer value. You really should state that every time, because I don't want, like, if k is 1/2, that's not going to work, so k has to be an integer.
Where did the 330 come from?
Quadrant 4, so in quadrant 4, if the reference angle right there is 30, you want this angle, so you do all the way around 360 minus 30.
What's that little thing in between the K and the double bar?
It's like a curved E, it means it's an element of. If you prefer to write k as an integer in words, you can. This is just the shorthand.
But we have to put that every single time.
Yes. Other questions on that? Let's look at this problem. Okay. Where do we begin? We've got more than one trig function here, first of all. So it's not as simple as the other one where I can just get the sine or the tangent on the side by itself. There are different options for how to proceed. You can try using some identities and things along those lines. You might also just try, you notice I have cosine more than once. I am going to add over my cosine theta. Oops, if I could write, that would help. So we have cosine theta, cotangent theta, plus cosine theta equals 0. Okay, I can't add these together, but they are two terms, and what do they both have in them? Cosine. So what you could do is factor out your cosine. That leaves you with cotangent theta plus 1. Now I have two things multiplied that equal 0. So what do we do? That equals 1 equal to 0. Okay. We have to solve both of these. The first one, cosine theta equals 0. When is cosine equal to 0? Bless you. This one tells me cotangent is equal to -1. So in what quadrants is cotangent negative?
2, 4.
Reference angle, when is cotangent 1? Degrees. Okay, so 45 degrees in quadrant 2 would be 180 minus 45, so that's 135. Quadrant 4, 360 minus 45 is 350. So for our final answer, we just have all of those. We got 3 different answers here.
Can make
4, yes. I don't know why I said 3. Sorry. Just a math teacher who can't count. Don't worry. Nothing to be worried about. Alright, let's try one more like that, and that'll be our last example for today. So what would we do here? Mm-hmm. There aren't any like terms, so what do we do instead?
Full same.
Yeah, opposite of distributing, factor it out. That leaves us a tangent theta minus 1. Anytime you get down to two things multiplied equal to 0, we set each one to 0. Okay, when is sine 0?
Would you prefer 360 degrees?
Okay, so 0 or 360, if you look at my directions, I put the bracket on the 0 and a parenthesis on the 360, so listed as 0 degrees. And the other time?
Be 180.
180 degrees. Okay, this one means tangent theta is equal to 1. So tangent is positive. What quadrants does that happen in?
1 and 3.
Reference angle, when is tangent 1?
45 degrees.
So 45 degrees in quadrant 1 is 45 degrees. In quadrant 3, 180 plus 45 is 225. And since I didn't say all possible solutions, I just asked for 0 to 360, you don't have to do the plus 360 degrees case. Any questions on that one? I probably do not have time to get through another example, so this is where we're going to stop for today. And we'll pick up with these tomorrow, the 6.1